this is Scruffy Teddy. The last object we worked with was a mould, this three-dimensional shape that you're looking at the moment. I want to turn this into reality, and so I need to turn this computer-aided design virtual model into a series of code that a CNC, that's a computer numerically controlled router, can recognise and start cutting. It's not as simple, however, as just exporting this to one bit of software or straight to the machine. We actually need to run it through an intermediate bit of software. So I'm going to export it as a stereolithography file to start with, and make sure that it's given a good name. Golden tag mould it will be. Notice that it's got the STL letters at the end. Don't worry about the ASCII binary. Just press OK. Now, stereolithography is a resin that's cured by laser in layers, and actually we're not going to use that process. Like I said, we're going to use a CNC router, but it will recognise it. This next bit of software is called Boxford 3D Geocam, and I'm going to be finding that STL file that I've just made. There we go, golden tag mould, and opening it in here. Now, to move it around, I'm using the left mouse button and pressing it when I move it around, and you'll see that it shows this 3D virtual shape appears. Now, I'm going to work through a series, so that's the first select model sheet, as it were, slide. I'm going to work through about 10 of these before I get to the next stage. This first one represents the angle. I can cut from the other side, or from different angles in case it comes in the wrong direction. I can also change the cut plane, and you will need to play with this. If you notice, if you look inside the bottom of the tag, you'll see at the moment it's coloured in yellow. Look at this little spot over here. If I move the cut plane up and down, basically, if they're right at the top, for example, there's the cut plane right at the top, it's cutting nothing, or hardly anything. It's just that very, very top layer. Right at the bottom, it'll cut the whole lot. I don't need it to cut the whole lot. So I'm looking in this little area over here, and that's not quite far enough. I'm taking it down. There we go. So that's about 8.5mm below the top surface is where it's cutting. At the moment, it's automatically defaulted to this Boxford model board, which is fine for MDF. It uses the similar sort of parameters, but the size that the model is 60 by 60 by 15. Unfortunately, the model board comes in these formats, so what I need to do is transfer those measurements here across to the sizes up here. So all I'm going to do is just type in 60, like so, and move on. And now it should fit in. You can notice 100% fits the material. I shouldn't have any problems. You can scale it at this stage. You might want to go back and make it slightly smaller or larger, but we'll stick with this at the moment. I wouldn't worry about the model work shift, and the tool that we're going to be using is a 3mm ball end cutter, rounded cutter, and for both roughing and finishing. The reason we've used the same tool for both is that we don't have to change it halfway through, and actually for this size of object 3mm is fine. We're going to do roughing and finishing. You don't need to worry about allowances, but there's no point in getting rid of all of this material. Notice this sort of red side here, there's no point in cutting it that away. And then we've got the roughing and finishing coming here. Roughing, it takes away a lot of material very quickly. And there's two different patterns in which it can do that: offset waterline and raster profile. You don't need to worry about the details of those, but we can come back and change them to make them to see whether it makes it faster or more effective. I'll leave it at offset waterline, just as I'll leave the finishing at raster profile. This is the final, virtually the final stage. I'm just going to let the computer now compute it, and you'll see what happens is a series of green and blue lines which represent the path along which the tool is going to be working. Now, these could have been typed in by hand, X 30mm, Y 30mm, and so on, with a particular speed for the router as it goes. This does it automatically, or effectively. I just want to check that that's going to work though, so I simulate the whole process. I'm going to slow it down a notch, and you'll see the tool cutting that particular shape out. Now, it's a little bit rough around here, although not too bad. But it's taken 15 minutes, hours, minutes, seconds to do the whole process. I can go back And I can change the roughing to that. I'll change the finishing to Z level milling, and you'll see it recalculating the tool path in a different format. Simulate the process again, and it cuts it out like so. 5 minutes 59 seconds, great, but it looks really rough. I've got a bit of a problem here, hasn't taken that away, and you can also see that slight purple section there which represents a collision, in other words a problem. This is the beauty of this particular bit of software. It's allowing me to trial a process without actually damaging anything or cutting any wood. So I'm going to go back and change it to combination milling, change that one to offset waterline, try it again, recalculates, simulate the process. Nice and neat, takes 19 minutes, but it looks good. I'm happy with that. I'm going to save that as it is, which is the next stage, and this is the post-process. So this is where it converts it into the code. The machine that we're using, there's a whole variety of different machines that we could output to. The one that we've got here is a Unimatic machine. Save it, and notice it saves it as an NCP file. At this stage, as well as saving it there, it might be worth saving it onto a USB flash drive so that we can take it across to the machine. And that's it, we're ready for the next stage.